Hello, I'm Ganesh Subramanian, a member of the simulation sub-team working in the secure cloud manufacturing project for 2 semesters now. So what you see on your screen right now is the simulation model of the existing test bed, which you can see in the Reconfigurable Manufacturing Systems Laboratory. So obviously, this modeling has been done using the software ProModel, which is a discrete event simulation software, free for all students and available on all Kane computers. So before we actually go deeper into how we as a team developed this model, let me show you some basic features of ProModel, and then I'll explain you how we built this particular model. So if you just click on the layout window, you have various tabs like File, View, Build, Simulation, Output, Tools, Windows, and Help. So out of all these, the most commonly used tabs would be Build and Simulation. So under the Build tab, you have again a drop down which has locations, entities, paths, and resources. So let us start by trying to define what each one of these are. So going back, build locations. So locations, if you see, are the machines as such, the CNC2 corresponding to this, CNC3 corresponding to this, the robot 1, robot 2, and again all the other components of the test bed. So to summarize, locations would be the CNC machines, the robots, and the conveyors which are existing in the test bed. So if you see across each one of these location, we have something called capacity, which is basically the capacity of that location, and then units, which is the number of units of this particular machine, which is 1 in our case. The capacity is also 1 in our case, meaning that the CNC machine can process only one part at a time. DTs represent downtimes. As of now, it is none, but then we'll see some tutorials where there are downtimes added on to individual locations. Stats, rules, and nodes are something which the software does on its default. So likewise, we have built different locations. As you can see, when I hover the keyboard, you can also see the parts moving on the screen. Okay, so the first step would be to get your locations on the layout. Second is the entities. Entities are the parts which move throughout the simulation. So here in the simulation, we have 3 parts, part 1, part 2, and part 3. And you can add different icons for each of them. So these are the parts, or basically the raw materials, which would be transformed to finished goods as a part of the machining process, right? So we have 3 parts in our simulation, and then this is the speed with which they move on the conveyors. We can change it if required, if we had the correct inputs. Otherwise, just leave it as such. And then this is again a default note. So we saw locations, entities, and then path networks and resources is something which we won't cover as of now and which we won't use in our simulation. Going back to the arrivals. So now that we have defined 3 different entities, part 1, part 2, and part 3, we have to say where each one of these parts would arrive in the simulation station. So part 1 in this case arrives at the infeed. So here is where part 1 would come when you begin the simulation. Similarly, part 2 and part 3 would also come onto the infeed, and the quantity in which they arrive is 1, which means that for every instance when a part arrives, it arrives in only one number. First time is something which you want to put. First time is basically if you have started the simulation and you want part 2 to come into the simulation after 10 minutes for the first time, so you would put number 10 here. So you would put time only and then 10. So we are not going to do that now. Occurrences are basically infinite. As long as the simulation runs, you get the parts coming at the in-feed. By frequency is where we define how frequently the parts come. Say the first part comes in the 0th minute, the second part comes in the 4th minute, the third part comes in the 8th minute, and so on. So IIT is a macro. I'll explain what macro is, and I'll also explain what logic is. Logic basically means that when part 1 comes, we are assigning it to be type 1. Likewise, for part 2 and part 3, we are assigning it to be type 2 and type 3. These will be used in basically programming or in the processing logic of the entire simulation. And there is an option to disable individual parts also if required. So we saw locations, we saw entities, we saw arrivals. Then the most important thing is the processing. So if you look at the screen now, there are some arrow marks. Some of them are not properly placed. I'll also show you how to fix them. So if you look at the first step under process, we see that entity as all. So here in our simulation model, we have assumed, or we have said that all the 3 parts are going through the entire processing network. If you want to be very specific, if you have specific routes for each one of the parts, you can also choose each one of them. But for now, we choose all. And then, so the simulation starts by having all the process come to the in-feed station. And from the in-feed station, all the parts go on to the ABB robot. So that is what this arrow in red is indicating, right? So we have something under operations. So these are basically variables and then deciding the product type. I'll explain this in a bit. And then, so now the parts have come to the in-feed, have gone to the ABB robot. Now next, from the ABB robot, all the entities move from the ABB robot to the conveyor 1. That is what this red arrow says. Likewise, we have from conveyor 1. So this is basically conveyor 1 here, this big loop. From the conveyor 1, parts move on either on to the robot 2 or on to the conveyor 2. So whenever I highlight each block, you can see that the arrow changes into red color, right? So we have defined some routing logic for each one of these, and that is all under operations. We can discuss one or few of them once after I explain the entire processing loop. So after all the parts have gone on to robot 2, we see that the parts move on to CNC 3 or CNC 4, and then from CNC 3 they go back to the robot 2. From the CNC 4 they go back to the robot 2, and now the robot 2 places the part onto the conveyor 2. And then similarly the same process would happen for this part of the loop as well, and after that the parts would be placed by this robot onto the, so the R1 robot places the final parts to the conveyor 3, from conveyor 3 the parts will be picked up by the ABB robot, and then the ABB robot puts the part back onto the outfeed. So this is basically all the processes involved in developing the simulation. And if you keenly observed what I was just saying, I missed or I did not explain much of the operations part. I did that on purpose because in order to understand more about the operations, there are some other additional things about ProModel which we need to know. So the first thing is the attribute. So you can access attribute from this shortcut button here, or you could go to build attributes as well. Both open the same window. So under attributes, you see that we have defined 3 attributes: type 1, type 2, and type 1, type 2, and type 3, each one specific to the 3 entities which we have created. So the type of these attributes are integers, and then the classification is based on the entity. So we have defined 3 attributes just so that the simulation model knows which entity corresponds to which type. Next, we have something called variables. Variables are basically used to evaluate the outputs out of a particular simulation model. So here we have over 1, 2, 3, 4, 5, 6, 7, 8, 9 variables defined for this model. You can have as many number of variables as you want within a simulation model. So the first variable we're tracking is the number of parts going in, and we have put an icon to it, meaning that you can see that particular variable displayed on the screen. So this basically keeps track of the number of parts going into the simulation loop. Similarly, we also have a variable to track the number of parts coming out of the simulation loop, so this is basically the number of raw materials going in, basically number of finished goods coming out of the test bed. And then some of the other variables which are not displayed on the screens are keeping track of the number of type 1 entities, type 2 entities, and type 3 entities. And also these are the entries and these are the exits of each one of these entities. And we also keep track of the WIP, or the work in process, so that when the simulation is run for like 100 hours and stopped at the end of 100 hours, there are still some parts which are being handled by the robots. Oops, I kind of created a icon, if you see. Yeah, so what I was trying to say is work in process is basically when you try to stop the simulation in 100 hours, there'll be still some parts within the robots or within the machines or on the conveyors. So in order to keep account of these entities, we have defined variable. Arrays is something which we have not used now. The other important thing which we have used in the simulation model is the macros. So what macros essentially do is they have a placeholder in the sense that instead of having to input the processing times for each one of the CNC machines separately or for each one of the robots separately, we can define one macro for all the entities together and input the value here. So basically here we have defined a macro called robot handling time and set it to be wait 0.5 minutes. So what this means is whenever this macro is called in the processing operation, then the entity would wait for 0.5 minutes. So this eliminates multiple times of inputting the same value and saves a lot of time in debugging and saves a lot of time in doing some scenario analysis as well. Process time 1 and 2 is basically the process time of the CNC machines 1 and 2, and we have set it to be 2.5 minutes in this case. So note that this can be a deterministic number as 2.5, and the default unit in ProModel is minutes, so you need not write minutes, or it can be a normal distribution of 2.5 mean and 0.2 standard deviation, right? So for simplicity of our model, we have used deterministic times. Likewise, we have process time for CNC machines 3 and 4 to be 7 minutes. In this case, note that there's something called options and we have used none for all of these. There's something called scenario parameter, resource, and cancel here. So factor is something which I'll explain after some time. IAT 1, 2, and 3. So these basically, if you remember, if you go to buildings and arrivals, we had something called the frequency inter-arrival time. And I told you here we had used macros. So going back to macros, these are the inter-arrival times for each one of the entities, and they're basically 10 minutes, 15 minutes, and 20 minutes. It means that part 1 comes into the simulation model, the raw material arrives every 10 minutes. For part 2, the raw material arrives every 15 minutes. For part 3, raw material arrives every 20 minutes. And then if you keenly observe, we've used something called scenario parameter for these. I'll explain this once we run the basic simulation. So yeah, I explained the macros. This is something which we have not used. So if we have all of these things defined, the attributes, variables, and the macros, we can go back to the processing and see how we've used each one of these under operations. For example, if you look at this, if attribute type is equal to 1, which means the part is 1, then the part should follow route 2. That is, the part would go from conveyor 2 onto conveyor 3 directly without having to go to robot 1. Likewise, these are very intuitive operations which are defined under processing. So, to give you guys a quick recap of what are all the basic things that are required in order to build a basic simulation model. So, you always start with the locations. Define as many number of locations as you can see on the real time. Then you go to the entities, define as many number of entities as you want the test bed to produce or operate upon. After locations, after entities, you would go to arrivals. Arrivals is where you say the entities come at so and so time and so frequency, and then finally you would build up the processing table. And then obviously you would have attributes, variables, and macros. So now that I've fairly explained how this simulation model was developed, let me just try to run the simulation for you guys. So in order to run the simulation, first you go to simulation options. Here you have the output path where the simulation file will be saved. Run name, you can put in a name. Time only, so we are going to run this simulation for 100 hours. Time units default to hours. And then clock precision, output, replications. You want to see the animation, so we won't disable it. And rest other options are good. So just click on it and then say begin. So if you see, the simulation is started, but this is like a fast forward tab. So if you slightly drag it on the right, you can see that the time clock has started ticking, and then there goes the first part, and then you see that the variable tracker also keeps on increasing. So now at this point of time there are 6 entities in the system, and then 1 is exited. So likewise, so this is like a very slow simulation model. If you want to increase the speed of it, you can increase the speed of it, and then the time is ticking there. If you want it to be very fast, you can also have it super fast. If you want to really observe what is happening in the system, if the process which you developed is actually happening in the simulation model, you can run it very slowly and then keep track of the product movements. So I'm going to run the simulation real fast now. So yeah, I want to see the results. So results of the simulation model in ProModel are typically presented in an output viewer. It is a very compact way of representing the results, and it also allows the user to do a lot of other things, do post analysis of the simulation. So this is how the result viewer, output viewer looks like. So basically, if you look at the scoreboard, you can observe that part 1, part 2, part 3, there were 596, 398 and 298 exits respectively, and each one of these parts spent 30 minutes and 34 minutes in the system, and then the average time in operation was so and so. So this table also says that part 1 was an operation 99.6% of the time, part 2 was an operation for 98%, and part 3 was an operation for 100% of the time. This graph here gives the location utilization for the various locations which have single capacity. Note that the conveyors have multi-capacity, and they are listed here. Conveyors and the robots, basically. Yeah. So from the scoreboard, we can see that when the simulation has been run for 100 hours, part 1, so many number of part 1 components have been produced, so many numbers of part 2 have been produced, so many of part 3 have been produced, and each one of them have spent an average of so much time in the system. So what this means is, if the production plant wants to, increase the production of part 1, they would need to go back to the simulation, change the parameters with respect to part 1, and then when they run the simulation again, they can observe the change in part 1. Like that, a lot of interesting things can be done by analyzing the results of the output viewer and tweaking back the simulation model once again. You can also see the results, the same results which are, which we saw on the dashboard, can be seen on a separate basis as well. We don't have any resource here, and then there are some time plots which might be sometimes interesting to see, as shown here. This is basically saying, when you run the simulation for so many hours or days, these are the values of the particular variable. Yep, so these are basically the results which we get out of the simulation. So with this, I'll stop the training module for the ProModel basic layout which we developed. Yep, thank you so much.